Okay, so the pilot of the airplane executes a vertical loop, right? So guys, here they are saying that this is a vertical loop. What does this mean? What's the difference between this problem and the previous problem? If I have a vertical loop, then the weight should be shown in the free body diagram. Yes, we will see the weight, all right? So we will see the weight, which in part follows the path of a cardioid. R is equal to 101 plus cosine theta. So I know the equation of R in terms of theta, not in terms of t, where theta is in radians, all right? If the speed at A is constant, so this is the speed. Here it is 85 meters per second. So I know the speed, guys, it's 85 meters per second. I need to determine the vertical reaction the seat of the plane exerts on this pilot when the plane is at A. So I'm gonna find the normal force. He has a mass of 80 kilograms, right? So this is what I should do. Now, the first step ever is to draw the free body diagram. I know the equation of R in terms of theta, which means I have to use the cylindrical coordinates, because in normal and tangential coordinates, I don't use R, right? So R is given, which means I have to use the cylindrical and cylindrical coordinates. Now, if this is my free body diagram, if this is, let's say, the passenger or the pilot, all right, what are the forces exerted on this pilot? I have the weight, of course. So there is a weight and there is a normal force. And this normal here, in this case, will be opposite to the weight, or it will be in the vertical direction, since at this angle here, the tangent, guys, is horizontal. All right? Guys, since the tangent at this theta is horizontal, then, guys, am I lagging? All right, I'm gonna repeat, guys. At this theta only, when theta is equal to 0, at this theta only, guys, the normal force will be vertical. Now, if I take another theta, let's say this one, the weight will always be downward, but the normal force in this case will be perpendicular to the tangent on this point, to this path, and this will be the normal. So, and at any theta, guys, any will not be vertical, except if theta is equal to 0, because at this theta here, all right, at this theta here, the tangent to the path is horizontal, which means that the normal will be vertical. Do I have any other force? Do you think that, guys, that I have any other force? You're listening, guys? You're listening? Is there any other force? No, guys, there's no other force, because there is no, in the given, there is no friction, there is no resistance of air. So these are the forces exerted on this pilot. Okay, guys? All right. So how to start? In fact, I should indicate the cylindrical unit vector. So I'm going to indicate UR and U theta. UR is always outside the radial side. So this is UR. And U theta will be perpendicular in the direction of theta. So this is U theta. Guys, in the first section, your colleagues asked why UR is outside the radial side. Because in fact, guys, you should recognize the difference between UR and U normal in tangential and normal directions. In tangential and normal direction, always the normal unit vector is towards the center of curvature. Now here UR is always outside the radial side, so it's opposite to UN, all right? So don't be confused. So U theta will be in the same, it is perpendicular to UR, but it is in the same direction of theta. Since theta here is counterclockwise, then U theta will be counterclockwise from UR. Now I don't need to do anything in the direction of U theta, because the forces are always perpendicular to U theta. So what I'm gonna do is to do the sum of forces in radial direction is equal to M A R. Now what is AR? As you know, guys, AR is R double dot minus R theta dot squared. So I'm gonna start by finding AR. So what is AR? AR, in fact, is AR is R double dot minus R dot squared, all right? So this is AR. Now, I know that R double dot is given in terms of theta, so I need to find R dot and R double dot in terms of time. I know that, so R is equal to 200. Okay, let's write them. So I know that R is equal to 201 plus cosine theta, all right? So what will be R dot? Which means, guys, that R dot will be minus 200 theta dot sine theta. So don't forget, guys, theta dot, because this is the derivative of R with respect to time. It's not only with respect to theta, all right? And then R double dot will be equal to 200 theta double dot cosine theta minus 200 theta dot squared, sine theta minus 200 theta dot squared cosine theta. All right, guys? Okay. So now, in order to find AR, I need to find R double dot. I know that theta is equal to what at this point, guys? At this moment, theta is equal to what? Theta is equal to what, guys? 0. Which means, guys, that this term will vanish because sine theta will be 0. All right? All right? Sine theta will be 0, so I don't have to find what is this term. Now, what about this term? Do I know, guys? I know that cosine theta will be 1 because theta is 0. But do I know theta dot? Do I know theta dot, guys? Do I know theta dot, guys? In fact, I don't know theta dot, but I can find it because I know that the velocity equation is equal to radical r dot squared the components in radial and transverse direction plus r theta dot squared. All right. So let's do it in the new slide. So I know that 85 squared, which is the velocity at this point, is equal to r dot squared plus r theta dot squared. And I know, guys, that r dot squared, I go back to this equation, r dot squared is minus 200 theta dot sine theta, which is also 0 when theta is equal to 0 because sine theta is 0. So it is 0 plus r theta dot squared, which means, guys, that 85, now I'm going to remove the square again, is equal to r theta dot. All right? So this is theta dot, don't forget. And this means, guys, that theta dot is equal to 85 over r. And what is r? It is 201 plus 1, since theta is 0, so it's 400. And this means that theta dot in radians per second is equal to 0.215 radians per second. So whenever, guys, I know theta dot, I can find AR. And this AR will be equal to minus 27. It is only the second term because also the first term is 0. And then, guys, I can apply sum of R is equal to MAR. What are the forces in radial direction? If you go back to this free body diagram, I only have minus n plus the weight, right? So minus n plus the weight, which is known because the mass is 80 or 85, 80 is equal to MAR, and then you can find the normal force, and this will be equal to positive 2.95, which means it is in the correct direction. All right, guys? Any questions so far? Any questions so far, guys? You listening? All clear. All right, so I'm gonna move to example 10.